Hello everyone, greetings. We are presenting the prototype for IFG Hackathon 2022, the Analysis Hub. We are the team Inevitables. As we can see, we are being greeted by a user-friendly and dynamic homepage. In the homepage, we have the login and sign-up pages. On scrolling down, we can see our vision and goal we have tried to implement in this project, with the real-world data that was made available to us thanks to Traffik Analysis Hub. We have tried to provide the analysis for the data provided across multiple areas mentioned in the problem statement, ranging from traffic analysis in Malaysia to the data analysis related to money laundering across multiple regions. Going through the sign up page to provide the required details, which will help the users to create a unique user account, which then will be redirected to the login page where the users can log into the Analysis Hub dashboard. On coming to the home dashboard, we can see a bunch of different sub dashboards: risk profile identifier, money laundering identifier, KYC identifier, traffic analysis identifier, and palm oil sector identifier. A few additional research features that we have added: the first one being the related cases search, second one the Google Scholar search. We can use Google Scholar to read the scholarly or reported incidents on traffic analysis in a specific location, and followed by a world data map. Kibana login. Since the dashboards and data are linked together and the datasets are classified, we need to log into the Elastic Engine using this option. Only when the user logs into the specific Kibana account, they will be able to access and view the visualizations of the data we've created. Let's visit the traffic analysis dashboard. As soon as we log in, we are presented with the first data visualization, which is a graphical representation of the data that shows the gender of the victims across multiple locations in Malaysia subjected to trafficking. And once you scroll down, the visualization for cases in hotspot location, like whether the incident was registered, trafficker was arrested or not, etc., is being represented. And the next one is for transportation mode used for trafficking, followed by the source record for various reported incidents, articles, and data visualization of trafficking, which is represented as a table. The next visualization that is following the table is a data visualization if whether minors were included in the trafficking and the ratio of trafficker gender to that of the victim gender. And so, the advantage of using integrated Kibana dashboards is that we can customize the queries based on user requirement using KQL, as we can see here. KQL is really simple to use and is straightforward. We can modify to whatever IDs we need to filter the queries with which. Other additional options that we have included are to generate a PDF report or a PNG report on the go, which will create the data access easier. And the ability to redirect to the dashboard in Kibana is also provided so that the users can go in and make any necessary changes. And here, on clicking on read related articles, we can go to the IBM Watson data representation to read related articles on the incidents. The IBM Watson is an external tool for collecting analysis data for research purposes. And the purpose of viewing original data is actually to download the data view created in Kibana from the raw dataset user uploads to obtain a simplified data representation. Now let's take a look at the data visualization custom to the palm oil industry in Malaysia and nearby locations. Initially, we can see a heat map representing the locations of palm oil industries across the area. The data representation of the count of companies with their internal and external certifications obtained based on their susceptibility to human rights preservation and employee rights preservations. And the next data representation of unsustainable land acquisitions made by the companies, followed by it's a ratio of number of companies that has been recorded of being illegal in certain terms of the industry. Now let's move to the KYC data and its representation. In this dashboard, similar to the dashboards we saw in Traffic Analysis Hub, we used a sample dataset and rendered it to show missing KYC details such as PAN, Aadhaar, total number of records, unique record counts, and even incomplete profiles. Moving forward onto the money laundering profile data and its dashboard. The type of frauds that occurred are represented using a bar graph as types ranging from 1 through type 3. The type of action involved in the fraud, like whether it was a cash-in or a transaction, etc. And the next representation shows top values of fraud with the date of occurrence and the type along with the number of records. Now in the side panel, you can see a profile page where you can update or modify your profile details, since each user is provided with a unique account and the only condition is an organization Kibana to which belongs to the user who creates the visualization. and the user accessing the data also should be a part of this organization. This particular step enhances the data security and makes sure that the confidential data is only accessed by the people who are granted with certain access. We also have integrated an event calendar to schedule tasks for the users. With this, we are concluding our presentation. Thank you to Hackathon and IFG for providing us a platform, and thank you to Traffik Analysis Hub as it provided the access to real-world data that we were able to work with. Thank you. Once again, we are the team Innovatables.